Now in 16 we discussed one big model. Let us see another model now. It is given like this. This is, let us say, 4 ohms, 2 ohms, 3 ohms, 6 ohms, and connected like this. This is A, this is B. Now what is RAB? What is RAB? Okay. Now for this, I will discuss this model in class 15, I think. Let us forget about this one first. Let's take this part. Let us take this part now. This will be 2, 3, 6, 2, 3, 6 connected like this. This is B. Let us take it as O point. Let us take it as point O. Now, if you look at this one, I told you this R when you connect like this. See, between this point, let us say this point and this point, what we have 3 ohms. Between this point and this point, we are having 2 ohms. This, let us say, this point and this point, we are having 2 ohms. Therefore, let us take, we can just lift this to upwards. Just lift this to the upwards. Okay. Then this becomes 2 ohms like this. 3 will be like this. Let's get this down. Get this to the downwards. Connect this point to this one by bringing 6 like this. Then 6 like this. Now this will be B, this will be our O. Now what is the 4? This is 4. No, this is 4 ohm, this is A. Just if the 3 are like this and connect like this, I have discussed in class 15. So just lift this upwards, because this point and this point are same. This point and this point are same. Just lift upwards. Therefore, these two are same points. Lift upwards. Again, this point and this point are connected by Y. Therefore, these are same point. Therefore, lift it to the downward. Then 2 in parallel with 3, in parallel with 6, in series with 4. And what is effective? Now, 2 in parallel with 3 in parallel with 6 first. This becomes 1 by R dash is equals to 1 by 2 plus 1 by 3 plus 1 by 6. That is equals to 1 by R dash is equals to 6. 2 3s, 3 2s, 6 1. That will be 6 by 6 is equals to 1 ohm. The effect of this is 1 ohm. This will be 1 ohm in series with 4 ohms. This is B, it is A. Now these two are in series. Therefore, R equivalent is equals to 4 plus 1, that is equals to 5 ohms. 4 plus 1. Simply, we will get cash 4 marks. Simply 5 ohms. Then what we have done? If you consider this circuit, this lift upwards, because this point and this point are same. Between these 2 points only we are having 2 ohms. Between these 2 points only we are also having 6 ohms. Therefore, these 3 are in parallel. If you look at the circuit carefully. Now, next model is, let us take this one like this. You will not give like this, you will give like this. It will be like a circle. This will be like a circle. This is R, this is R, this is R, this is R, this is A and B. Now what is the effective resistance between A and B? What is RAB? It will be given like this. This is in the form of a circle, will be given perfect circle like this. Perfect circle like this. Now what to do? If you observe this circuit, see this point are same, no? Connected by a wire. This is equivalent to, this is A, this is R, this is point A, and this will be same points, no? This is another R. This is another R. This point, this point. This is B. Okay. This is R and R. This is R. To this one, this is R. Just have lifted this one to here only. Just have lifted this one to here. Just like I have done. Because there are single wire now. I have lifted this one, or we can take this point B. Now R in parallel with R. R parallel with R, that is equals to R by 2. So what I have done, just I have lifted this point to B2 here, B2 here, or you can take this one as B only, this one as B also, no problem. Okay, this one as B or previous, this one as B or this one as B, no problem, the same point, wherever it is, no problem. For R in parallel with R, this will be, this point is A, this becomes point A. Therefore, R in parallel with R is R by 2. This big circuit becomes R, this is B, this is A, this is R by 2 in parallel with R. This is equals to R in series with R by 2, R plus R by 2. That is equals to 3R by 2. Therefore, this becomes 3R by 2 in parallel with R. A and B. 3R by 2 in parallel with R. This is equals to 3R by 2 into R by 3R by 2 plus R. That is 3R square by 2 into 5R by 2. 2 gets cancelled, R gets cancelled. That is equals to 3R by 5. Answer is 3R by 5. Answer is 3R by 5. So this how it is one. So I have bring this point to this one. I have bring this B2 here. So B2 here like this. Actually this is like this. So I have bring this B2 here. Now what happens? R in parallel with R. This R in parallel with R and the point A2 here, because these two are same points. Point A2 here. Therefore R in series with R parallel with R. That becomes R in series with R by 2. That is 3R by 2 and parallel with R. That becomes 3R by 5. That is the effective one. Now let us see the previous year's problems now. Previous year's problems. In previous mains, in 7/1/2020, 7/1/2020, shift 1. Shift 1, one problem was given. Find the current I in the given circuit. Find the current I in the given circuit. The circuit is something like this. This is 1 volt. This is 1 volt. This is 1 ohm. This is 1 ohm. This is 2 ohms. And this is 2 ohms. Calculate the current I. What is the current I asked you to calculate? What is the current I? This is the given problem given in 7 January 2020 shift 1 problem. Okay. This costs 4 marks. Very simple problem. So you have to calculate this current I. This current I. Now, so if you look at this one in parallel with, let us calculate the effective resistance and then calculate the current first. First calculate the entire current. First calculate the entire current by calculating the effective resistance. See, if you look at the circuit, this will be 1 in parallel with 1. What is 1 parallel with 1? 1 in parallel with 1 in parallel with 1 is 1 into 1 by 1 plus 1, 1 by 2, that is equals to 0.5. The effective of this one is 0.5. This will be 0.5 in series with 2. In series with 2 ohms. To that one, 2 is parallel. To that one, 2 is parallel to that one, and 1 volt is connected. 1 volt is connected. See, these two are in series. This will be 2.5. Effective will be 2.5. This is 2 and this is 1 volt. And the current is I. Now the current, let us say I dash. The current is I dash. Now here, see, this 1 volt appears across this one. 1 volt appears across 2 volts. Isn't that not? So 1 is same, no? This 1 volt same appears across this one. Therefore, what happens to the current through this one, current through this one. Let us take current through this. Take this one as I dash. We do a current through this one, I dash. I dash is the current through 2.5. Now the same 1 volt appears. This is the parallel combination of 2.5 and 2. Parallel combination of 2.5 and 2. Therefore, same voltage appears across 2.5 and 2 volts. Same voltage appears across 2.5 and 2 volts. Therefore, what is the current I dash now? I dash is equals to V by R. What is V there? V is equals to 1. 1 by 2.5. 1 by 2.5, that is equals to 10 by 225, that is equals to 5 2s 5 5, that is equals to 0.4 amps. Therefore, the current through 2.5 is 0.4 amps. Similarly, the current through this one also 0.4 amps only. Therefore, the current here we got as 0.4 amps. Now, what is the current? This will be like this. This is 0.4 amps. This is 1 ohm. You are asking, this is I. This is 1 ohm and this is 2 ohms. This is 0.4 amps. This is 0.4 amps current is passing. Let us take it as I dash. I dash is equals to 0.4 amps. Here this 2 will be there. This 2 will be there. We don't require that 2 because we have current this one, not this 2. Therefore, then neglect that 2. Now, how to get the current I? This 0.4 is splitting. This is series combination. This is one series parallel, one is 0.5 and 2. These two are in series. Therefore, same 0.4 also flows through these 2 ohms. No problem. But now, what is the current here is, so 0.4 and this 1 ohm and this 1 ohm equal splitting. Therefore, this will be 0.2. This will be 0.2 amps only. 0.2 and 0.2. 4 ohms. 4 ohms splitting into two branches. This is because they are having same resistors. Therefore, this is 0.2. This will be 0.2. R, I have given you a formula in the previous class also. This is total current I. This is I1. This is I2. This is R1. This is R2. Then what is I1? I1 is equals to I into R2 by R1 plus R2. And I2 is equals to I into R1 by R1 plus R2. These are the current division formula we have discussed in this after completion of series combination and parallel combination. Discuss this one. Then what is the current I now? I is equals to I dashed total current. I dash I total current is 0.4. Total current 0.4 into opposite resistance 1 ohm by some of the resistances 1 plus 1, that is equals to 0.4 by 2, that is equals to 0.2 ampere. Therefore, the current there is 0.2 amperes current flowing in the branch, and the answer is 0.2 amperes. So, what we have done? Nothing. Very simple thing. Therefore, here this is the calculate the effective resistance of this branch. Effective resistance of this branch is 2. 1 volt. Same 1 volt appears across this branch and also this one because they are in parallel. Therefore, we are having the voltage across this one. Therefore, the current to that branch is, this is one parallel with one is 0.5, 2 is 2 and 2 is 2. Therefore, 1 volt appears across this one. Therefore, the current is, therefore, the current to this branch is 1 volt means effective resistance is 2.5. Therefore, I dash is equals to V by R. V is 1. R is 2.5, therefore it becomes 10 by 2.5, that 10 by 20, that is equals to 0.4. Now the current to this branch is 0.4 we got. This is 0.4 we got. Now that 0.4 is flowing from 1 ohm and also to this 2 ohms. But 2 ohms, these two are in parallel to series this one. Therefore 0.4 splits into 2 branches. Again these two combined and then comes out as again 0.4. Therefore, here 0.4 splitting into 2 same resistors. Therefore, effect will be half. Therefore, 0.4 by 2. 0.4 by 2 is 0.2. Or we can use the formula. So, if the current I is flowing, total current is I. It is splitting into I1 and I2. Resistors are R1 and R2. Then what is the current I1? I1 is equals to total current I into R2 by R1 plus R2. I2 is equals to I1 into I2 is equals to I into R2 by R1 plus R2. Like that, the current I is equals to total current 0.4 into opposite resistance 1 ohm by sum of the resistances 1 plus 1, that is equals to 0.4 only. So this is the model given in 7-1-2020 shift 1. We will discuss more models in the class 18.